Teacher Jonathan's studio.
And Mercy
Proudly brings to you
constructions from the year 2000 to year 2019, Part 1.
Welcome.
The diagram below represents two sides of a quadrilateral PQRS. To get point S, construct angle QRS 30 degrees and angle SPQ 60 degrees. Join RS, SP and diagonal SQ. So the first thing we want to do is to construct angle QRS, which is 30 degrees. QRS, S will be somewhere here. So I take my protractor, I place it like that. This is the baseline. So I'm using the outer scale. You can see the 0. We always start measuring from 0. So we count up to 30. 0, 10, 20, 30. Then I put a point where that is. Then I join with a line from point R. I draw a long line. This is 30 degrees. QRS will be somewhere along this line. Then the next thing we are told, angle SPQ. S, which will be somewhere here, PQ will be 60 degrees. So I want to measure 60. We can also construct 60. If you want to construct 60, you are supposed to stand at point P, reduce this compass, make a semicircle like that, just like a semicircle, a curve, a big curve. Then you, with the same radius without disturbing, you cut that arc like that. The angle formed will be 60. Then you join. Or you can just take your protractor and place it at this point and just measure 60 when you're at point P. Remember, at this time we are going to use the inner scale. The 0 is inside. So we count 0, 10, 20, 30, 40, 50, 60. You can see it's exactly the same as the one we constructed. So the line for 60 will be here. So where this line meets with that line, that is our point S. We are told to join RS and SP, and they are already joined when we were constructing, and diagonal SQ. So the diagonal is the one we are going now to draw here, where they have met, and this point Q. We now draw the dot diagonal of the quadrilateral of the four-sided figure. Then the question is, what is the length of SQ? So to measure SQ, we just extend our compass to give us the radius of SQ like that. Then we take our ruler, and remember, when you are measuring, you start from 0 mark and you place it like that. Place it properly like that. It gives us 5.2. So the closest answer here is 5.3. In the exam, you are allowed plus minus 0.1. So 5.2, and you have the nearest answer there is 5.3. You can see the other answers are far away. 3.5, 10.2, 12.9. So we get that line is 5.3. Which one of the following diagrams shows arcs that lead to the construction of a perpendicular from point P to line XY? A construction of a perpendicular from point P to line XY. So I will demonstrate using this white paper here how to construct a perpendicular from point P to line XY. Then we choose the answer from the choices given here. So to do that, we are supposed to stand at that point P. Then we are supposed to reduce the size of the compass in such a way that it can cut two sides of the line. Like if it's too wide, it cannot cut, it can only cut one side. So you reduce it until it can cut two sides of the line like that. So it can cut on this side and it can cut on the other side like that. So you can either make it a whole curve or you just cut it like that and like that using the same radius. It just cut on two sides of the line while we are standing at that point where we are dropping the perpendicular. The next step is to stand where the arc has cut the line. Then we make an arc below here. Using the same radius, we stand where the arc has cut the other part of the line. Then you make an arc. Then now we are supposed to drop the perpendicular from P to the point of intersection of the arcs. Remember, a perpendicular that has been dropped from a point to a given line cuts the line at 90 degrees. So if you look at the choices, you find this is wrong, this is wrong, this is the right one, which is exactly the same as this one. Where we stood at P, we made an arc, then you're standing at this point, we made an arc, standing at this point, we made an arc. So we dropped a perpendicular from point P to line XY, correctly at choice D. ABC shown below has been drawn accurately. What is the size of angle CAB? Let's identify CAB. CAB. So it's the angle formed at A, that angle there. So to do this, if it's drawn accurately, we take our protractor and we place it. The first method I will use is use AB as the baseline. So I'll place it there using AB as the baseline. And then when I use AB as the baseline, I start with this 0, the inner scale. Because this line, you see, it's corresponding with 0. We always start counting from 0. So we grow with this 0 up to this line here, where we meet, where the angle is formed. So we count 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, then 100, then 101. It has just passed 100 by 1. 101, choice D. Now we can also measure using AC as the baseline. This AC, like that. When you use AC as the baseline, now we shall use the outer scale, because the 0 is outside here now. So we count from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 is up to here, then past 1 degree, which is 101 degrees, which is choice D. Now, candidates fail when they don't look at the scale. For example, the way we started, if you just place it like that and you don't mind about the scale you're using, you just rush to get a 79. You'll just measure what you see here. And here you can see 79. You can see it's just about 79. So those are the candidates who don't check about scale. So when you place it here, it's good to know which scale are you going to use. The baseline is this one, so we are using the inner scale. So we'll grow with the 0 up to this line. So it's 40, 50, 60, 70, 80, 90, 100, then past 1 degree to get 101. So it's good to determine the scale you are using first before you measure. And always, if the answer is 101, the wrong scale, when you add the wrong scale answer, you get 180. This is 081. So the wrong scale answer is the one which comes straight away when you just place your protractor like that. If I place it just like that, I see 79, which is the wrong scale of 101. So be careful not to be trapped by the wrong scale. The other thing you can also do, so that you are not trapped by the scale, is to look at the type of angle you are measuring before you start measuring. This is an obtuse angle. It's more than 90. So your answer must be more than 90 degrees. So you look at the choices, you eliminate A, you eliminate B, and you also eliminate C. Actually, you are left with the right answer. So before you measure, just look at the type of angle you are measuring. It's obtuse. It's larger than a right angle. It's more than 90. So it's going to be giving an answer which is more than 90. So it's good to do the first things first. Below is part of the construction of a trapezium PQRS. Complete the construction such that angle PQR is 56 degrees. PQR, the angle formed here will be 56 degrees. Then the question is, what is the length of side RS? RS will be the line formed up here. So before I construct that trapezium, I want to demonstrate a bit of some properties of a trapezium. I want to draw a trapezium here. Just a sketch. This represents P, Q. Then we have point S. Then we have PQR, which is 56 degrees. And then we have SR there. So in a trapezium, we know that it has only one pair of parallel lines. So line PQ is the one parallel to SR. These two are not parallel, but this pair is parallel. It is a quadrilateral which is unique. It has only one pair of parallel lines. So having been told that this is 56 degrees, you know that if I draw parallel lines and a transversal like that, if this is 56 degrees and these lines are parallel, the angle which is here and this angle, they are said to be co-interior. These two angles are co-interior. They add up to 180. So to locate the angle up here, I'll just get 180 subtract 56, which gives me 124. So the angle formed here will be 124. Now to get this angle here, because it's already drawn, I just measure this angle here, and after I measure, I subtract from 180 to get this angle formed here, because these two are co-interior. If I demonstrate, just draw parallel lines and a transversal. This angle here will be co-interior with this angle formed up here. So the two should add up to 180. So back to our construction. We first measure this angle PQR, which is given here. We take our protractor. We place it properly like that. Then we are using the inner scale, the outer scale, because this is our baseline and the 0 is the one outside. We can't start measuring from 180. So we count up to 56 from this point. 0, 10, 20, 30, 40, 50, 55, 56, up to that dot. Then we draw a line. Like that. So SR will be somewhere along this line. Then, as we have said, if this is 56, the angle formed up here will be 124. So we want to know the angle formed here, because after we get this angle, we shall draw this angle, and the line that will be drawn here will come to meet with this line here to form point R. So we first measure this angle here by placing our protractor here. Always be careful when you're measuring. This is our baseline, so we are using the outer scale. So we grow from 0 to 10 to 20, 30, 40, 50, 60, 65, 66. Just 1 degree after 65, which is 66. So this angle formed here is 66. So the angle that will be formed above here, as we have demonstrated, will be 180 minus 66, because the two are co-interior. It will be 4, 7 minus 6, 1, 114. So we are going to measure 114 degrees from here, which will be co-interior with this 66 we have measured. We are using the inner scale. You can see the 0 is inside. So we shall grow from 0 up to 114. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Just 1 degree before 115, which is at this point. So now from point S, we join point S to this point here, like that. So this has helped us. Now this is 66 and this is 114. This has helped us to locate point R, which is there. That is our point R. Remember, this was 56, and if we measure this angle here, we shall find it is 124, because the two of them are co-interior. to add up to 180. And the question is, what is the length of RS from S to R, where the two lines came to meet? So we take our compass, we place it at point S, we stretch this one like that. Then we get our ruler, starting from the 0 mark, we measure and we get exactly 4.5, which is choice C. It is 4.5 centimeters. The diagram below is an incomplete parallelogram, PQRS. Complete the parallelogram and draw diagonals QS and PR to intersect at T. Then the question is, what is the size of angle PTQ? So before we construct this, just a demonstration here to explain some properties of a quadrilateral. So in a quadrilateral, we know that it has two pairs of parallel lines that are also equal. Each opposite lines are equal and parallel. Like QR and PS are parallel and they are equal. They are opposite each other, they are parallel and they are equal. They measure the same. If this is 10, this will be 10. The other opposite lines, the other pair, this line and this line are equal and also parallel. If this is 6, this will also be 6. So that is one property you need to know before we construct. So when we come here, these are the two lines of the parallelogram. So one thing we know about this parallelogram is that the line here, QR, there's another line here which is exactly the same size as this line here. So what we are going to do is we are going to take the radius of QR, like that, and then stand at point P, because we want another line which is equal to that line, and just make a big arc like that. Just an arc which is having the same radius as QR. Then we measure. We know this line QP is supposed to be the same as the line which is here. So we measure QP. We measure QP. And then we transfer the same measurement here. And we cut, having the same radius as QP. So where this line intersects, this arc intersects with the other arc, that is our point S. So we call this point S. Then we use our ruler to join the points. So we have completed. Then the next thing is to draw the diagonals, as we are told to draw the diagonals. QS, that's one diagonal, and then the other diagonal PR, like that. And then we are told they bisect at T. It's good to name all the points. Then what is the size of PTQ? From P to T to Q. So we want that angle there. It is the angle we want to measure. So we take our protractor, we place it like that, and then we determine which scale we are using before we start measuring. Remember, we are using the inner scale, the 0 which is inside. This is the baseline. So we are using the inner scale. So we grow with this 0 until we meet this line of the angle. So we count 0, 10, 20, 30, 40. Then after 40 we have how many degrees? We have 1, 2, 3, 43 degrees. That is choice B. So we count again. From 0 we go to 10, 20, 30, 40. Then some few degrees after 40 before we reach to 45. Some 3 degrees, we get 43. But those who don't mind about the scale, after they place the protractor they have placed, they just look at what they can see, and they can see 137, which is choice D, which is very wrong. So we have to know what we are measuring. We are measuring an acute angle, and if we measure accurately, we have got it is 43 degrees. We subtract from 360 to get the inner one, because the two of them, they add up to 360. So we need the inner one. The examiner wanted the inner one. So we measure the outer one, which is obtuse, then we subtract from 360 to get the inner XYZ. So the shorter line is going to be our baseline, like that. We place like that, and we are using this inner scale, the inner 0. This 0, we grow an angle starting from 0. So we start from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. So it is 140 degrees. We subtract, this is the 140, the outer one. Subtract from 360, we get 220. The inner one is 220, choice A. So even before we measure, there are some of the things we could have done. Before you measure, you just look at this angle you're about to measure. It is obtuse. It's more than 90. So when you look at the choices, we can eliminate. We know that here we expect the answer to be more than 90. And then when we subtract from 360, that's the time we shall get the inner angle there. So you can tell some of the answers which are extremely low. Construct triangle PQR such that line QR is 8 centimeters, angle PQR is 45 degrees, and angle RPQ is 55 degrees. What is the length of line PQ? This construction, you have to start with the only given line. You're only given one line and two angles. So you start with the baseline, which is QR. So this is point Q, and then we measure a radius of 8 centimeters. Then we cut from Q to get point R. So this is point R, which is 8 centimeters. Then the other thing we are told is that angle PQR is 45 degrees. P is somewhere up here, PQR is 45. So we measure 45 degrees from this point. Remember, we are using this as the baseline, so we use the inner scale where the 0 is inside. We go up to 45, 0, 10, 20, 30, 40, in between 40 and 50 is where we have 45. And we draw a line. P will be somewhere up here. Then we are told RPQ is 55. Now that is where the trick of the question is. RPQ is the angle formed at P. RPQ is the angle formed at P, and we have not yet located point P. So this one we have known it's 45 degrees, and we expect the angle up here to be 55, but we don't know where P is. So the trick of the question was there. So what we do is we know angles in a triangle add up to 180. So we get the two given angles, 45 and 55, add them together to get 100 degrees. Then we subtract from 180, we get 80 degrees. So 80 degrees is for R, because it's angle P, which will be 55, and we have not yet located P. So we first construct this 80, we measure this 80, which we know it's supposed to be here, because we have found the other angle. After being given 45 and 55, we added the two to get 100, then we subtracted from 180 to get 80. So this other base angle here will be 80. For those candidates who put 55 here, they ended up getting a very wrong answer. 55 was supposed to be for point P. So we now measure 80. This is our baseline. So we are using the outer scale. 0 is outside. We grow up to 80. 40, 50, 60, 70, 80. 80 is here. Then we join point R. Like that. So now we have found point P. That's our point P. So now if we measure this one, we'll find that it is 55. It has just brought itself. It's supposed to be 55. Yeah, you can see. From using the inner scale 0, 10, 20, 30, 40, 50, in between 50 and 60 is 55. So we were to calculate this angle here first because we could not measure the angle up here before locating where P is. So after measuring this 80, it was to locate point P where it is. Then we want the length of line PQ from P to Q. We just measure PQ. So we take our ruler and we measure PQ, which gives us 9.6, exactly 9.6, which is Joyce's dog. Construct triangle XYZ such that side YZ is 6 centimeters and angle YZX is 50 degrees and angle ZXY is 35 degrees. So in this construction we are only given one line and two angles. So we start with the baseline YZ, which is 6 centimeters. I take my ruler. That is point Y. Then I want YZ, which is 6 centimeters. So I measure 6 centimeters with my pair of compasses. Standing at point Y, I cut an arc, radius of 6 centimeters. This becomes my point Z. Then now we are told that angle YZX is 50 degrees. So Z, the angle formed at Z, YZX would be 50. So I take my protractor, I measure 50 degrees. When measuring, you have to be very careful with the scale. I'm using the inner scale because this is my baseline. Outer scale, sorry. The outer scale, the 0 is outside. So this is the 0. We always start growing an angle from 0. So we grow up to 50. 0, 10, 20, 30, 40, 50. Up to there. So we draw a long line past that dot. Always when you're doing construction, make sure that your lines are as long as possible. Then we are told again in that question, angle ZXY is 35. ZX is somewhere up here and Y is here. ZXY is 35. So we cannot be able to draw that angle which is 35 degrees here. So we have to do something before we draw this angle here. So what we want to do is we find this angle, the angle formed at Y. And that is where the trick of the question was. Those candidates who ended up putting 35 here were wrong because it's not angle Y which is 35. It's not angle ZYX, it's angle ZXY. So what we do is we get the two angles given, 50 and 35. We get 85, subtract from 180 to get 95. Because the three angles in a triangle add up to 180. So the angle formed here will be 95. This one which will be formed here is 35 and we can't draw it because you don't know where point X is. So we find this angle here. This being 50 and the one above here 35. We add the 2, we subtract from 180 to get the base angle here, which will be 95. So we measure 95 and again we be careful when you're measuring. So this is the baseline. So we are using the inner scale. We always start measuring from 0. We are using the inner scale. So we start from this 0 here up to 95. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Then between 90 and 100, that's where we have 95. But for candidates who will be careless, will just look here without determining which scale they are using. They see 90 and 100, they say 95 is here. That's wrong, because you have not started from 0. You must know the scale you are using, your baseline. My baseline is this one, and I'm using the inner scale. So I grow with that inner scale up to 95. So every question has its own tricks, and we have passed all those tricks. So we now join point Y and this point here, like that. We have located point X, and if we measure this angle, we shall find it is 35 degrees. This is 95, this is 50, the remaining is 35. So if we measure it, we find it is 35. And there it is, in between 30 and 40, 35. So we now go to the question. What is the length of side XZ? XZ, this line here. So we take our divider or compass, we measure the length of XZ, like that. Then we take our ruler and measure, which gives us 10.4. And in the answers, we have 10.4 as choice B. But for candidates who thought that after getting this 50, they put 35 here, they ended up getting a very small XZ. And maybe one of the answers here among this, between these two, was the wrong answer there. They chose that one. So it's very good to be very careful when you are doing construction and follow instructions. So this is 95. We have got XZ is 10.4 centimeters. Below is part of a construction of a quadrilateral KLMN with diagonals meeting at center O. Complete the construction and draw a perpendicular from L to meet KN at P. So the first thing we are going to do is to complete the quadrilateral by simply just joining the points K and L, L and M. Remember, quadrilateral is a four-sided figure. M and N, and K and N. Then we are supposed to draw a perpendicular from L to line KN. To line KN. This is KN. KN, this line here, from L to line KN at P, to meet it at P. So we are dropping a perpendicular from point L to line KN. So to drop a perpendicular from L, we are supposed to start at that point. Then we stretch the compass in such a way that it can cut two sides of the line, and here you see that even if I stretch, it can only cut one side. So what we are supposed to do in such a case is we are supposed to prolong the line. To make it possible to cut two sides of the line. So we prolong the line in the same direction it was extending, like that. Then we stand at L, we stretch it in a way that it can now cut into two parts of the line, like that. Yeah, just cut. Just cut on this part and on this part. So what we do is we stand at where the arc has cut the line, then we make an arc up here. We go to the other place where the arc has met the line. We make another arc. I repeat the other arc. Then we now join from L to where the two point to where the is the point of intersection, that one, up to KN, like that. And remember, it is to cut line KN at P. So this place where it is cutting at KN is called P. And what can tell you that it is true? When you drop a line, a perpendicular from a point to a given line, it should cut it at 90, and you can see it's cutting at 90, so we are very accurate. So that's one thing that tells you that it has cut properly. Then the other thing we are told is, what is the length of LP from L to P? We measure LP. We take our compass, we measure using we stretch to get that radius, then we get our ruler, then we measure LP, which is coming to 4.4 centimeters. It is 4.4 centimeters. The other way you can also drop a perpendicular from a point. I can also show you another shorter way of dropping a perpendicular from a point. How to drop a perpendicular from a point by use of your set square. By using your set square. If you want to drop a perpendicular from a point using your set square, it's easy. Remember, we have said that the perpendicular dropped from a point cuts that line at 90 degrees. So what we do is we get our set square, which is 90 degrees. Then we try to match it with the given line, this given line here, until it matches with point L. You move it, the 90 degrees to be on this side where it is going to cut it. So you match it until it touches point L, like that. Then you draw that line. That line is the one we want, because it is to cut it at 90 degrees. Just repeat again for those who have not understood. If I want, remember, when you are dropping a perpendicular from a point L, and you are dropping to this line here, this line is going to cut the given line at 90. So what you do is you take your set square, put it at 90 degrees to that line, and then you move horizontally until you meet point L, making sure that you are moving at 90 degrees, matching that line. So it's going to cut it at that part there. So this line now, which is cutting it at 90 degrees, is the one we want. So we measure it, which gives us the same 4.4 centimeters.
In the figure below, RPQ is a triangle. Point O is inside the triangle. Join RO, PO, and QO. What is the size of obtuse angle POQ? So we join the points as we are told. RO, PO, then we have OQ. Then we want the size of angle, obtuse angle POQ. That one I've underlined there. Before we measure that angle, we need to look at some of the choices which are obviously very wrong. By defining angles here, we know the smallest angle is called acute angle. An acute angle which looks like this is less than 90. It's always less than 90. It is followed by a right angle. A right angle is exactly 90 degrees. After right angle, that's the time we go to obtuse angle. An obtuse angle is more than 90 but less than 180. It's less than a straight line. And then we have the largest angle is called reflex. which is more than 180 and less than 360. So the type of angle we want is this, obtuse, which is more than 90 but less than 180. So some answers like 54 are already very wrong. So we are left with 114, 120, 126. And the funny part of it is when you place our protractor, the first angle that will come straight, if you don't mind about the scale, will be this 54 to confuse you, which is the wrong scale of the right answer. So when we place our protractor, for example, like this to measure, we determine which is our baseline, which one matches with our zero. It is this line here. We are using the inner scale. We are using the inner scale to measure. So you can see without looking at the scale, we have 50 and 60. It is showing 54 here. So if you don't know what you are measuring, how to check the scale first, you'll see this wrong answer first. So we are using this inner scale. We are matching, the baseline is here and we are using the zero inside here, the inner scale. So we are going to move with this zero until we meet the line here. So we go 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Then from 120, we move 125, then 126 there, which is choice dog. So we can also measure like this. We can use this as the baseline to measure this angle. If we use this as the baseline, remember, if we use this one as the baseline, we shall use the outer scale. This is the baseline and we are using the zero outside. So we grow from this zero until we meet the line we want here. So we grow 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 125, in between 125 and 130, then 126. So we get the same answer. So it's very good to determine the scale and also to identify the type of angle you are measuring, because you can eliminate some tricks which are there to trap you. Construct triangle JKL such that JK equals to JL, which is equal to 5.5 centimeters, and KL is 7 centimeters. Draw the bisector of angle KJL to meet KL at M. Then the question, which of the following statement is correct from the construction? So the first thing we want to do is to construct what we are told to construct, and I will use line KL as my baseline. So I start with KL as my baseline. So I'm going to measure 7 centimeters. Standing at that point, I cut. This is point K and this is point L. And then the other thing I'll do is to measure JK, which is also the same as JL. So JK, remember to use the centimeters, not millimeters, is 5.5. In between 5 and 6 is where we have 5.5. Katikati ya 5 na 6. Then JK or KJ is the same as 5.5. With that radius of 5.5, I make an arc here. With the same radius, I stand at L. Remember, we are trying to locate point G. Cut an arc here to intersect with the other arc, because the two lines are the same, 5.5. So the new point is J. Then I join J to K. And I join J to L. And I have my isosceles triangle, which has two lines which are equal. This is 5.5, this is 5.5, this is 7 centimeters. Then the other instruction is that draw the bisector of angle KJL. A bisector of an angle, in short, I bisect this angle here. I bisect angle KJL, which is formed at J. So to bisect an angle, you stand at that where the angle is formed, reduce the size of the compass, cut an arc that will cut the two lines like that. Then remove the compass, stretch it a bit more, stand where the arc cuts the line, and then make an arc there. Stand where the arc cuts the other line, make an arc there. Then the point of intersection, join with J, like that. And we are told to meet line KL at M. Then which of the following statements is correct from the construction? We go one by one. Triangle JML is an isosceles triangle. JML is not isosceles because you can see this is right angle. JML, this one I've shaded here, that's a right angled triangle. So that choice is wrong. Triangle JKL is right angled. JKL is the entire triangle. JKL, and it is not a right angle. That's wrong. Line JM is perpendicular to KL. Line JM, the line that is passing here, is perpendicular to KL. Very true, because it is cutting it at 90 degrees. Perpendicular means cutting at 90 degrees. And if we measure, we find that this JM is cutting KL at 90 degrees. So that is a very correct statement. It's cutting it at 90 degrees. It's perpendicular to KL. So that's the right one. Then angle JKL is 45. JKL, we have to measure that one to see whether it's 45. We place our protractor there. Remember, when you are measuring, you have to determine which scale you are using. I'm using the inner scale. This is the line which is at the base. So I go 0, 10, 20, 30, 40, 50. This is 50 degrees, not 45. 45 is supposed to be in between here. So that's wrong. So the correct one was line JM is perpendicular to this line. It cuts it at 90 degrees. The triangle KLM drawn below, construct the perpendicular bisector of line KM to cut line KM at N and line KL at P. So a perpendicular bisector of a line is a line that cuts another one at 90 degrees and divides it into two equal halves. So to bisect line KM, I need to stand at one end of the line at point K, stretch the compass to be more than a half. A half is like somewhere here, and then I stretch it to be more, but not a lot because the space I have here is not very big. So I make an arc on one side of the line with that radius which is more than a half, and I make another arc on the other side of the line while I'm standing at K with a radius more than half of that line. Then I go to M with the same radius to the other end of the line. I cut an arc to intersect that arc, and then I go to cut an arc to intersect the other arc. Then I join the 2 points of intersection with a line. And remember, I was told the bisector to cut line KM at N. So this is point N, and line KL at P. So this is point P. So you can tell that it is a good perpendicular bisector by seeing that it is cutting at 90 and it's dividing it into two equal halves. Then the question is, what is the size of acute angle KPN? KPN, this acute angle here. And before we measure it, it has already been called acute. And we know an acute angle is less than 90 degrees. So some very obvious wrong answers is 35, 55, and 90. Sorry, the wrong answers include 145, and 90, the ones which are not less than 90. So these two are not acute. So we are left with 55 and 35, which are acute. So the answer lies between 55 and 35. So we now get a protractor and measure angle KPN. Remember to determine the scale. This is my baseline, so I'm using the outer scale. The 0 is outside. So I grow from 0 to meet this line. I go 10, 20, 30, 35 degrees. I can also place it like this. This time this is the baseline, and we use the inner scale. So I grow from the 0 inside up to till I meet this line here. 0, 10, 20, 30, in between that and 40, which is 35. So those who just place protractors without minding about the scale and the instructions given, they choose answers like 145, the one they just see here, because they can see between 140 and 150 is 145, which is choice A. So it's good to determine which scale you are using so that you can know the right answer, and also the type of angle you are measuring. You are measuring an acute angle, which is less than 90. Complete the construction of a parallelogram PQRS where line PR is a diagonal. What is the length of line QS? So this is one of the tricky questions that has ever tricked candidates in K.C.P.E, because most of them completed thinking that this is a line and this is another line of the parallelogram. So they continued the parallelogram to complete it like this, which was wrong. So this is a diagonal, this one inside here, as we are told. So if I sketch here how it is supposed to look like, it's supposed to look like this. This is P, this is Q, this is R, and this is S. So the diagonal is this one here, PR. So this is the diagonal, and this is one of the side of the parallelogram. So I first join Q and R to get the other side, this side here. Now you can see the diagonal is inside, so the two remaining sides would be here and here. This line here, there's a line opposite here, which is the same as this one. So I get this measurement, PQ, the radius. I stand at R, and I make an arc with that radius. There's a line here opposite, the one we have just drawn here on this side, which will be the same as this line. So I stretch to get QR. So I draw, I make an arc here to cut, to make that line. So I now join and I join this point here to complete my construction. So this is my point S. So as we were told, this is a diagonal. You can see now it's inside. So now we draw the other diagonal. Then the question is, what is the length of QS? We have to measure now this QS. We get the radius, we just measure with a divider or our compass, and we get QS is 6.5, 6.6, 6.6, and our choices, we have 6.7, 7.0, 3.8, 9.1. So 6.6 is close. The closest answer there is 6.7. So in the construction, you are allowed an error of 0.1 plus or minus 0.1. So they can't put answers which are very close, because they know you can slightly make a slight error. So we have the diagonal QS was measuring 6.7 centimeters.